Today we're going to discuss about the sets operation. At the end of this lesson, the learner should be able to accurately list the elements of the union, intersection, and difference of two sets. Accurately list the elements of the complement of a set, and correctly solve problems involving sets. Okay, so here are the essential questions. How do you determine the elements of the union, intersection, and difference of two sets? How do you determine the elements of the complement of a set? Okay, union of sets. It is the set that contains all the elements of both given sets A and B. Okay, for example, the union of sets A and B is denoted by A union of B. Okay, if set A is equal to A, C, A, and set B is equal to B, D, F, then set A is the union of B is equal to A, B, C, D, A, F. Okay? All you have to do is to write or list the elements found in set A and also the elements found in set B. Okay? Okay, next is the intersection of sets. Okay, it is the set that contains all the elements common to both given sets A and B. Okay, for example, the intersection of sets A and B is denoted by A intersection B. Okay, so if set A is composed of 1, 2, 3, 4, 5. Okay, and set B is composed of 1, 3, 5, 7, and 9. Then set A is intersection of set B is equal to 1, 3, and 5 because 1, 3, and 5 is also is is found both set A and set B. Okay? Next is the difference of sets. Okay, it is the set that contains all the elements in a set A which are not in set B. Okay, so for example, the difference of sets A and B is denoted by A difference B. Okay, is if set A is composed of 1, 3, 5, 7, and 9, and set B is composed of 1, 2, 3, 4, and 5. Then set A difference of set B is equal to 7 and 9. Okay, so these are the elements that have that have that don't have the same or don't have in common in set B. Okay, so these are the elements or numbers that are left. Okay, so next is complement of a set. It is the set that contains all the elements in the universal set that are not in set A. Okay, for example, the complement of set A is denoted by complement of A. Okay, complement of set A. Capital A in apostrophe. Okay, if a set U is equal to 1, 2, 3, 4, 5, and set A is 1, 3, and 5, then the complement of set A is equal to 2 and 4. Okay, so next is, okay, for example number 1, consider the universal set. Set U is equal to A, B, C, D, E, F, G, H, I, J. Okay, so letter A defines set A as the set of the first three vowels, and set B as the set of the first four consonants in an English alphabet. And letter B lists the elements of the union of A and B, or set A and B. Okay, list the elements of the intersection of set A and set B. Okay, so letter A defines set A as the set of the first three vowels, and set B as the set of the first four consonants in the English alphabet. Okay, for the solution, letter A, we list the elements of both sets A and B. Okay, so set A is equal to, okay, so only the first three vowels. So meaning to say you have A, E, and I. Okay, that is the set A. Okay, how about B? So the set B is a set of the first four consonants. So we have the consonant is B, C, D, and F. Okay, so next, list the elements of the union of A and B. Okay, so the solution, since we already identify set A is equal to A, I, and B is equal to B, C, D, F from item 1. So to get the union of two sets, we combined all their distinct elements. Okay, so whatever the elements found in set A and set B, all you have to do is to write all the elements found both sets A and B. Okay, so A union B is equal to A, B, C, D, A, F, and I. Okay, next, so letter C. List the elements of the intersection of A and B. Okay, so now let's have to identify the intersection of set A and B. Okay, for the solution, identify and list the common elements of sets A and B. Okay, so for the set A, we have A, E, I, and B is B, C, D, F. Okay, since the two sets have no elements in common, their intersection is a null set. Okay, so A intersection B is equal to null, okay, or an empty set. Okay, there's no common elements found in both set A and set B. Okay, so next, example number 2, consider the universal set as the set of integers from 1 to 10. Sets A and B are defined as follows. Okay, so sets A as is a set of all x such that is an even number from 1 to 10. Okay, while set B is a set of all x such that x is a composite number from 1 to 10. Okay, find the following sets. So letter A, we have set A union set B. Okay, and B, letter B, set A intersection B. Okay, letter C, set A difference set B. Okay, letter D is complement of set A. Okay, so we have to list what are the elements found in set A. Okay, list in roster form. So the U is, okay, for the universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for set A is an even number from 1 to 10. So, okay, what are the even numbers from 1 to 10? So we have 2, 4, 6, 8, and 10. Okay, for set B is a composite number from 1 to 10. Okay, what are the composite number? Okay, for set B is equal to 4, 6, 8, 9, and 10. Okay, so next is find the following sets. Okay, letter A union B. Okay, so to get the union of set A and B, we combine their distinct elements in the set. Okay, combine all the elements found in both set A and set B. Okay, we have set A union B is equal to 2, 4, 6, 8, 9, and 10. Okay, so now letter B, intersection. To get the intersection of two sets, we get the elements common to both sets. Okay, A union B is equal A intersection B is equal to 4, 6, 8, and 10. Okay, because these are the elements that have in common that is found in both set A and B. Okay, so next is difference. Okay, difference A, difference B. To get the difference A and B, we list the elements in A that cannot be found in B. Okay, so the answer is set A difference set B is equal to 2. Okay, these are the elements that cannot be found in set B. Okay, next is complement of set A. To get the complements of A, we write the elements in the universal set that cannot be found in A. Okay, we have complement of A is equal to 1, 3, 5, 7, and 9. Okay, these are the elements that cannot be found in A.